Hello everyone, in this video I'm just going to be talking about the chemistry of electroplating. Now electroplating depends upon electrolysis because that's what we're using to electroplate objects. Just a little recap, I have mentioned in a previous video, because this particular one is part of a sequence of ones on electrolysis and its uses and applications. We'll just say what electrolysis is. It's a process by which ionic substances are broken down into simpler substances when an electric current is passed through them. Now for that to work, ions, because ionic substances contain charged particles called ions must be free to move. And when ions are free to move in an ionic substance that is dissolved in water or when melted, we call that an electrolyte. And we're going to use that in this electroplating process. So electrolysis is used to electroplate objects. It is a useful process that basically coats a cheaper metal with a more expensive one. So let's make a quick note of that. So electroplating is when we coat a cheap metal with a more expensive one. That's essentially what we're doing. And one example of that is right here. We've got a bike in the corner. Now, the question an examiner might ask is, why might someone electroplate a steel motorbike with a layer of chromium metal? Now, aside from looking more expensive, chromium metal is much more resistant to corrosion. So that's one of the reasons why we can do this. So you can have a chromium plate over that steel coating on the bike. Now I've got a picture to the bottom left here. We can see that we've got a big block of silver in that. So what we're going to do is talk about electroplating with silver as our example. So as I said previously, the object that you want to actually electroplate should go where the negative electrode is. And I explained in my electrolysis video about which one is the positive and which is the negative. So here we've got a spoon. We've got a spoon, and the object to be plated, such as a metal spoon, is connected to the negative terminal of the power supply. So you can see we've got the negative terminal because we've got this E minus here coming down. So we've got this current, this electric current running through this circuit from the battery, and it's going to go down through the spoon and through this solution you can see in the beaker of silver nitrate that's aqueous, so it's dissolved in water. So we've connected the metal spoon to the negative terminal of the power supply. We've got a piece of silver connected to the positive terminal. So if I'll just put here a plus and a minus just to remind each other. And the electrolyte we've got, as we said, is silver nitrate solution. Now, as you can see in the picture, the positive silver ions move to the negative electrode. Here they're gaining electrons to form silver metal, and we say those ions have been reduced. So let's just have a look and just explain that for a moment. So here we have silver nitrate. When we run the electric current through it, we're going to ultimately get electrolysis happening of that particular solution. We're going to break that up and we're going to get separated Ag plus and NO3 minus ions being released, and because they've got a plus charge on the Ag on those silver ions, they will move to the negative end. Remember, like charges repel and attract charges attract. So because we've got a positive silver ion and a negative terminal, the positive ion moves to the negative terminal. So we've got here this Ag plus ion moving to the spoon that is acting as our negative terminal. If we were to do the half equation for that, then what we've essentially got is this kind of scenario. So we'll just throw an arrow to represent our half equation, and we're going to put a half equation down here. So we have Ag plus is one positive charge, and when it moves to the negative terminal, it's going to pick up an electron, so it's going to add an E minus. And remember, we use an E minus to represent an electron, and then we're going to form Ag. So essentially we're going to cover that spoon with some pure Ag, some pure silver. So we are silver plating that spoon. All of this silver, if you imagine, if I draw it in blue here, it's just going to go to coat the outside of this spoon here. Now, unusually, silver ions from the positive electrode go into the solution. And a question they might ask you is, can you explain why this would happen and give a half equation to represent the reaction at that particular electrode? So we've had from the silver nitrate solution, Ag plus ions going towards the spoon. But now let's think about this that I'll circle in red here, where this supply of Ag plus is coming from. So we'll just change colour to make it a little bit clearer. This here is a big block of silver. This is representing our positive terminal. Now, because of the nature of the electric current flowing through that silver, essentially we are oxidizing the atoms within that block of metal. Because it's the positive terminal and we've got a flow of electrons going from our sort of left side to right, if you like, from in that direction, essentially the electrons are coming away from the atoms in the silver. So that we're oxidizing them. So those Ag ion atoms, rather, if you like, are losing electrons to become Ag plus ions. So at the positive terminal, what we essentially have, if we draw the half equation here, is we have Ag atoms, remember, and they are losing, so we're losing some E minus, we're losing an electron to form Ag plus ions. And those Ag plus ions simply fall into the solution. So they become free, they go into the solution and increase our concentration of Ag plus. So you can see over time, essentially the left-hand side on this picture wears away, and the right-hand side becomes thicker because we're getting this silver coating on the spoon. And this is the fundamental principle to electroplating. You put the material that you want to actually plate the object in on the left-hand side. I say left, I mean essentially at the positive terminal. And on the right-hand side of this picture, on the negative terminal, you put the object like the spoon that you actually want to electroplate. And we're just working off a basic principle of electrolysis. Positive ions move towards a negative terminal. They become reduced, and we get a pure sort of coating of that metal on the object we want. And in this case, it's being pure Ag, pure silver. Okay, hope all that helps.